If a function is given and we have to transform the function from one value to a slightly shifted value, then how do the graphs of the function change, or what is the change in the look of the graph of the function? So we will study that under this little subtopic called transformation of graphs. Suppose we have a function y is equal to fx, then fx plus c, where c is a positive number, if the graph of fx plus c will shift c units upwards, because that is where you need the graph of the function to be so that the values match, right? So therefore fx plus c involves shifting the graph c units upwards. Vertical shift, fx minus c shifts the graph c units downwards. So the blue graph is the original graph, and the red graph, which is going c units below that graph, is the shifted graph by c units. Horizontal shift, if we have a function fx whose graph looks like that blue colored graph, then fx plus c shifts the graph c units to the left. Here c is a positive real number, so therefore fx plus c shifts the graph to the left by c units. Similarly, fx minus c shifts the graph c units to the right. Reflections, so f minus x reflects the graph about the y-axis. Okay, so instead of x, if we replace the whole thing by minus x, the whole graph of fx gets reflected about the y-axis like that. Reflection, so instead of replacing all the x with minus x, if the whole function gets minus sign attached to it, then the graph of the function will just flip about the x-axis. So here it is shown as an example. The blue colored graph is the graph of the original function, and the dotted red colored graph is the same graph when it gets multiplied by a minus sign. So blue colored is fx and red colored is minus fx. As you can see, it's a kind of reflection about the x-axis for this function. Vertical stretching and shrinking. So that happens when the function gets multiplied or divided by a non-zero real number. So c times fx makes the graph shrink vertically. C times fx stretches the graph vertically, depending upon whether c is a number which is less than 1 or c is a number which is greater than 1. Okay, so for example, if we have y is equal to fx is equal to sin x, 2 times sin x will make the graph longer by 2 units. Say this is the approximate graph of sin x, then 2 times sin x will make the graph grow bigger vertically. And so on. Similarly, sin x by 2 makes the graph smaller. It does not change the interval or the period of sin x, it just makes the graph smaller. Okay, so that is how the stretching and shrinking of the graphs work. So this figure shows the example of fx is equal to x square and gx is equal to 0.35 x square. So if the blue graph shows y is equal to x square, the yellow colored graph shows y is equal to 0.35 x square. Similarly, horizontal stretching and shrinking. When instead of c being multiplied by the function fx, the value of x everywhere in the function gets multiplied by a non-zero real number, then the graph stretches horizontally if the value of c is less than 1, and then the graph stretches vertically if the value of c is greater than 1. Okay, so for example, fx is equal to x square and gx is equal to 2x the whole square. So therefore the yellow colored graph is the original graph of y is equal to x square, and when 2 gets multiplied by x, the graph shrinks horizontally. And thus, summarizing everything, transformation of graphs, the multiple transformations that we can get by the different manipulations of a function are horizontal translation or vertical translation or stretching or shrinking of graphs and reflection of graphs. Okay, so y is equal to x square is a basic function which we need to reflect, shift horizontally, vertically, etc. So y is equal to minus x square reflects the graph about the x-axis. Y is equal to minus of x plus 5 the whole square shifts the graph horizontally by 5 units. Y is equal to minus of x plus 5 the whole square plus 3 shifts the graph vertically up by 3 units.